Okay, this video we were looking at some example of the strain, and I'm taking out example from a PowerPoint. Okay, so let's take a look at it. Due to a loading, the plate is deforming to the dashed shape, and determine the average normal strain along the side AB, and also average shear strain in the plate at A relative to the X and Y axis. So it will be original shape is what? Original angle between those two lines are pi over 2, right? Now, how do we solve that? We learned in the previous video that our normal strain, epsilon, is equal to delta L, changing length over original length. And our gamma, which is our shear strain, is going to have a couple of expressions. It's pi over 2 minus the final angle, right? So this final angle will be theta prime here. Also, that's theta. Also equals theta. Also, the angle theta is often small. That's going to be equal to tangent theta. For tangent theta, which means it's opposite, delta over adjacent, this height. And we call this height as y. So those are the equations to solve the normal strain and the shear strain. So let's get to it. To find epsilon, normal strain, do we know L, AB? This is side AB. What's our original length? Side AB is from here to here. That's 250 millimeter. That's our original L naught. And how about delta L? B used to be here. Now B has been changed over here now. So what's our AB, the length now? That's going to be this color, right? It's going to be the length of that. How do we figure out the length of that? Okay, let's take a look. This whole thing shifted 3 millimeter to the right. So this delta is going to be 3 millimeter to the left due to symmetry, right? Symmetry. So if that's 3 millimeter and the whole thing lowered down, how much? 2 millimeter. So if this is 2 millimeter, what's going to be our y? Would that be 250? This entire length to AB minus 2 millimeter would be 248 millimeter. So knowing those two, can we figure out this hypotenuse? So this hypotenuse will be equal to, in this triangle, if we're looking at this triangle here, right? We know our delta is 3. We know the height here is 248. Then we can use hypotenuse to figure out the final length of this hypotenuse. So that would be square root of 3 millimeter square plus 248 square. That's going to be the final length. L prime minus L naught. It's a change, so we're going to minus original length, which is 250. So with that, we can calculate our epsilon. So plug it in. Let's take a look. Put in the calculator. So what do we have? 248 square plus 3 square. And we're going to take a square root of that. Then we're going to minus 250. Then we're going to divide by 250. So I get very small value as negative 7.93 times 10 to the negative 3. And what will be the unit? That's right, no unit. The length over length canceled. We talk about strain has no unit. And we have a negative value, which means what? It's instead of lengthening, elongating, it's actually shortening, contracting. So it's negative value. So that's our epsilon. We finished answer the normal strain. We're done with that. Now we're going to figure out the shear strain. Gamma. We already know gamma have couple of formulas here. 3 actually. Which one will be easy? That's the one you will be using. So here it looks like we're going to use delta over y. That will be immediate answer, right? Gamma is going to be equal to delta over y. Tangent of this angle. Tangent of this angle, delta is shifted 3 millimeter. 3. And our y is 248. Then that's your gamma. So 3 over 248. That gives answer of 0.012. Unit? No unit for strain. So that's your 2 calculation. Let's just double check, see if it's the same answer as the slide. Okay, that looks right. That looks right, 0.121, right? Okay, so that's it. So that's a simple example of using strain concept to calculate both normal strain and shear strain. That's all for this video. See you next time. Bye.